Hi, uh, I'm Abhishek, and I'm on the product architecture team on the Auth0 side. And what I do on a day to day is heavily involved with building identity standards, building with developer tools, and interacting with our customers, and building interesting solutions to everyday problems. And today, I'm going to be talking about securing humans in the loop with Auth0, and in general, what human in the loop is becoming, where the tech is going, and towards the end of the presentation, I'll do a demo. So if you're not familiar with human in the loop, it's a technology that we all use now to interact where an agent needs our assistance. But if I take a couple of steps back and go back to where we are today, I wanted to share a story. About 6 months ago, I built this slide when I was trying to talk to a few customers and a few internal folks. And back then, we had this idea that agents can do things for me fully autonomously. They would be running fully remotely and doing things for me without manual human intervention. Since those 4 months, that's now a reality. Today, there are agents like Cursor's background mode or Codex by OpenAI that can fully write code and fix some small issues, and teams are now interacting with them in Slack as opposed to a code editor. And that brings to the point that generative AI, in general, the technology behind AI agents, unlocks new modalities. And within the last 2 years, we've seen a lot of proliferation of these interactions that were never possible before. We now collaborate in our code editor with a person that's almost always coding. It's like pair programming, but with 10 different Claude codes running at the same time. We also have fully autonomous agents now that can do things like monitor my calendar or search for a flight, find the best coffee that I like, and accommodate my purchasing decisions in their search. And these are becoming increasingly more common today. And as we move to a different frontier, we're starting to see fully autonomous agents talking to fully autonomous agents and accessing services that are not built into them. For example, MCP, agent to agent, and fully agentic workflows are currently heavily in development and deployment across the world. And if you look at it from a different angle, in the past 4 months, we went from, or the past 2 years more so, we went from a human having access to 3 apps, which is a very simple single access model. The person could be role-based, they could be an admin in one app, they could be a collaborator in another, and they could be a read-only mode in the third app, which is static. To now, you can have a human and two agents accessing the same apps. Maybe they're working on the human's behalf, maybe they're not. And if I were to just take a quick math example, on the left side, you would have 3 lines that are going from the human to the apps. Now you have 12 on the right side. This is a highly dynamic system. In many scenarios, the person's access and the agent's access is similar. And these are the cases where we model agents as applications. But in some other scenarios, it may not be the same. For example, if you wanted to give it some complex task, you may not want to give it access to your entire Google Drive. You might want to limit it only to the documents that it should have for that task. So we're slowly starting to see a task-driven access model. And folks have been talking about this since 2024. Even when MCP was very young, Alex posted about the MCP auth support being like a top priority. Organizations and developers are currently in that trench curve where you start with like a very cool demo very quickly, and you have like dev keys or root keys running, and then you now want to deploy it in production, and you don't have the necessary controls of being able to make it secure. So on our side, we identified 4 key requirements that accommodate these scenarios. And in the way I like to think about it is, if an autonomous headless agent is working on my behalf, it needs to know who I am and what context I'm working in. Me working on my personal laptop is very different than me working on my work laptop, and those have different accesses. My work laptop might grant me access to a plethora of SaaS tools, while my personal laptop has my iMessage. And this agent needs to be able to work with me asynchronously. And lastly, every time I work in collaboration with this agent, that has to be fine grained. So let me give you an example of what async interactions is and how they play in the human in the loop ecosystem. Let's take a very simple calendar agent. I want to give this agent a task to make sure Friday is clear on my calendar. Today, the agent might say, sure, I will do this for you. And the first thing it will do is it will access Google Calendar or iCloud Calendar or Microsoft Calendar on my behalf. Now, it needs to fork or split a worker process that's going to monitor my calendar continuously. Suppose a meeting comes up from my boss on Friday. I wanted to give it the instructions of allowing me to focus on Friday. And now there's an 8 a.m. meeting from my boss. At this point, the agent needs to decide, should it respond with this note to my boss saying, I want to focus on Friday? Or, given the context of the meeting, should it reach out to me to ask for an override? This is a scenario where the agent needs the human to be able to resolve a decision dilemma. Another example could be deep research, and which is one of my favorite features of AI. And Gemini, Claude, ChatGPT, they do an excellent job at going through hundreds or thousands of documents, consolidating them, and connecting the dots. For example, say you're a developer and you're getting a large number of bug reports from some release. You could ask your agent to go ahead and analyze the traffic logs. It could discover things on its own. For instance, we enabled a feature flag in Android, and a specific region and version of Android is at fault. In order to do this, it would need to start fetching bug reports. It would need to read, analyze, compress, and consolidate all of its findings. And if it finds new information, for instance, it reads a Google Doc that someone wrote down and attached a video, a multimodal agent can extract information from this data. However, it would be limited by not having access to this file. So how should an agent in that case request access to a document that it has not got access to before? And in this case, the agent is running fully autonomously. It's a shared agent between the team. So it's completely possible that I might not have access to the file either. And if this experience sounds a little bit off, we do this every day. Most of us are developers. We like to focus in our code editors, maybe GitHub issues. Product managers work in Jira, Confluence. Architects tend to do a mix of things. Then design works in Figma. If you're a new employee trying to find and getting up to stream on something that's currently moving fast is very hard. And with AI, we can make it very, very simple. So that's a use case that today requires some level of human interaction. And then the last one, let's say we wanted to mark all abandoned tasks all pending tasks as abandoned. And this is using a old, basic remote API that does not support MCP. It's just a tool call. What if this API results with, I need additional security, something with RFC 9470, which would be, it would tell the agent that the access token you have isn't sufficient. I need a stronger form of verification that the person intended to do this. How should the agent mediate in this scenario if it were to run in background? The way I personally think about them is these experiences are more collaborative and not access control. And trying to solve a collaboration problem with access control has extreme limitations. For instance, access control mechanisms are role-based or usually coarse-grained. You want a more fine-grained system where you could imagine a colleague reaching out to you for a task that they're trying to perform, and they need to know information in a doc that already exists. And so we approach it today in three different ways. There are capabilities that are built into the agent. There are agentic access as a service products that try to resolve this whole thing. And then there's the most simple one that we all do. We add Slack or human layer or one of the tools that are going to try to send a human a approval message and so on and so forth. But as async interactions become more and more mission critical, they start doing things like deployments, they start trading stocks, they start moving your meetings. You want to be able to have stronger assurance for security. There's a difference between an agent's access and a person's access that needs to be accounted for. An agent and an API must work together. And if they are built with different systems and it's a third party system altogether, that can be risky because now the API needs to support a completely different form of authentication. In many of these scenarios, you might want assurance that the person who is approving the request is the person who was the intended recipient. And an example here could be if I left my Slack open and I got an approval prompt, it's very possible that someone else might have clicked it. Not a problem for some scenarios, but if this was a stock trade, that's a challenge. And we are going to see agents trading stocks before probably the next few years. If it wants to delete something, if it wants to be able to revoke, you want that assurance level and the audit log to follow through. And we also don't want to send push notifications for every single thing to the end user, because we have seen that if you send a user an approval notice every single time, they will click the allow all button, and that significantly reduces the ability to constrain a runaway agent. And it opens up completely new attack vectors. An example is very recently there was an MCP server that was able to trick an agent into disclosing information from another MCP tool. So these new attack vectors are going to become increasingly popular. And we ideally want to make agents and async interactions or auth for headless agents secure from the get-go. So let me switch to a demo that I built, or I should say Claude and I built, which, just give me a second. So what you're seeing on my screen right now are two apps that I wrote. One is Superbot, and this is a full feature-rich agent that is like ChatGPT or Claude. Now, I'm going to start the agent, and I'm going to try to sign up. I'm going to use Face ID and a passkey to allow that sign up to happen. This is using a native interaction just to onboard the user as fast as possible. This app is fully native. It does not have any web components. It does not have any web interaction out of the box. It's built using Vercel's SDK, and it has a worker and the background process. So I can ask it, how are you? And responds with what ChatGPT or GPT 4.1 mini does. I can ask it what features it has. And this is where things get interesting. With Vercel's SDK, I added Google Calendar, Google Drive, a bunch of stock trading third-party app, and the ability to manage background tasks to demonstrate background scenarios. So I can start by asking it, what's on my calendar today? It's going to call the tool to list calendars, and it's going to see that I haven't granted it access. At this point, I'm going to go ahead and go to my tools and add Google as an applicable tool. Now, this uses Auth0's token vault to add Google for my account. And I didn't want to share my personal email, so I made one just for this day. If you have any questions about this demo or any of the talks that I'm talking about, I'll hang out in the YouTube chat after the demo. And I'd be more than happy to share source code. I would love to learn how you're addressing these problems too. Once the auth dance with Google is complete, I can now go back into the agent and ask it, what's on my calendar today? It's funny that my typing is a little bit rough, but I'm sure generative AI will eventually get there. It calls three tools in a multi-step process. It lists my calendars, it chooses the current date, and then it lists calendar events. And it saw that dev day was a blocker on that calendar, and I wanted it to say hi. So here's Superbot saying hi to dev day. Now, let's make it do something interesting. I wanted to take the example of keeping my calendar open. And so I'm going to give it a background task. In this system, this background task is just a cron tab that runs every few minutes and tries to run scheduled tasks. In a real scenario, you might be using some kind of a durable execution environment, and you might have a worker that's completely separated out. Architecturally, the background worker is completely separate from the front-end application and the API. And the security assurances are very different. So now I'm going to go ahead and wait for it to do its calendar pull. This, in a real world scenario, this could be me working or me just going on with my day, vibe coding or doing whatever I want to do. And eventually I'll get a push notification from Superbot. And I'm going to pause it for a second. There's certain things here that we're doing. Instead of this just being a approval message, this is using rich authorization requests to express that the action the agent is trying to take is reschedule the meeting with my boss. And it's trying to reschedule it for a different date, and it wants my approval, and it has a little bit more context of what that implies. Now, the most important part here is that this agent at this point still has access to my calendar, right? So we can protect the tool and we can try to make the tool a little bit more wrapped in code. But at the foundational layer here is that the agent is accessing calendar on its own behalf. And here it's choosing this authorization request to determine if I would approve this or not. This is a scenario where potentially there you can override it and you might be able to challenge or overwhelm the agent. The ideal way to do this would be to wrap the change meeting itself into an approval system. But for this demo, the current method should be sufficient. So I'm going to approve this prompt, and it should go ahead and allow me to have a focus time. Now, let's talk about an app that I already had. I had built a second app, which is a stock app, which allows me to trade stocks. And this is all fictitious companies. No real financial data is actually occurring. Let's see what I have on my portfolio. So in order to do that, I'm going to go back to the tools and go to the stock trading app. This stock trading app is built as a resource server, and it follows the PRM spec. It can express which tools are high security, which tools are public, and which tools require some additional authorization. Now, once I approve it with the OAuth dance, and in this case, both parties are using Auth0, I can now ask my agent, does it have access to my portfolio? To do this, it will obtain the access token for the third-party app from Token Vault, and it will call the API, which allows me to see what's on my portfolio. Now let's make things a little bit more interesting. What if I wanted to monitor and sell any stock that loses more than 5 to 10%? Again, there are systems that do this today, but for the sake of example, let's try to make it a little bit more inference-driven. This will create another background task that's going to monitor my stock portfolio every minute. Now, in this scenario, if the push notification came from Superbot, it's very likely that the stock app does not have a strong assurance level. Instead, the assurance should come from stock app. So let's see what that looks like in practice. I'm going to wait for the push notification to show up. And there it is. Now, in this case, not only does the trade approval required message is telling me that it's trying to sell, it's trying to sell 100 shares of Acme, it also has information that this was Superbot that requested this access. So right now, if you were to visualize it, Superbot has a worker that's waiting for this push notification to be approved. And once I approve it, that worker will obtain a credential that allows it to trade stock on my behalf for one time. Now I resume that and approve more dialogues. And now the worker will obtain the access token, call the stock trading API. So if I go and refresh it now, my sale would have been performed. In this case, this legacy system that was originally API driven can now move into MCP world and still be able to leverage the same assurance levels that it had before. There's no difference between StockApp's own trading platform and Superbot, but the user is made aware that when Superbot is trading for them, it's not the same as themselves. And I can always query the stock portfolio again, and Acme is gone. So now I'm going to ask Superbot to close this demo, but I want you to think about three things here. In the single demo, we saw different ways of interacting and determining who a user is and how they sign in. We also looked into how the users, we also looked at the difference between the access on the bot's behalf, the access on a user's behalf, and the access between, and the scenario where the access is given to the bot on the user's behalf, but still requires additional steps or decision making from the end user to confirm. In my mind, async interactions need to be very simple but high secure. They're kind of the opposite of building everything into the agent and building everything as a simple tool. They're a wrapper for a async agent to be able to interact with people, interact with other processes. But the key focus there is these are going to be dynamic and they need to adapt very quickly with the same level of simplicity as human as a tool. Our SDKs make it extremely simple. If you want to try this demo out, or if you want to build your own agents that use async authorization, you should install npm i-s auth0ai, and then followed by the package that you're using. Auth0ai supports Cloudflare Workers, Genkit, Llama Index, LangChain, and Vercel SDK. And the rough work that you have to do is wrap your code with async user interaction or with async user confirmation. And that allows you to request a very rich binding message as well as rich authorization details. The snippet is an earlier version of my own app, and that's how the bot requests approval from the third-party API. In closure, async interactions blur the lines between a person having an access, an application having an access, and insert this scenario where inference can make new decisions, unlock new things it needs access to. Our solution to that is built on open standards. It's built using Guardian, which is a which builds in the push notifications and passkeys and brings in our strong phishing resistant factors. It leverages our security policy, so everything you saw in the demo is fully audited and logged in Auth0's logs. It has built-in non-repudiation. Only the end user who was intended to be able to see this request should be able to see and approve it. It's very simple for users because they're already used to once in a time getting a push notification from their bank or a high security app. And it's one line of code for developers to be able to wrap your solutions on top of it. And for agent, this allows them to have a single source of truth where security context is separated out of inference space. Everything you saw today was built using CIBA, and it fails gracefully because if the CIBA notification fails, we could potentially send an email link or perhaps ask the user in chat to perform a full interactive authentication. And this works with across all topologies that are popular today. At this point, I can take some questions from the chat or have any thoughts from y'all. Are there any questions in the chat? Well, so one of the questions that I always hear about when dealing with push notifications and uh, just these agentic systems is if this stock app was to monitor you 20 times in a row and send you 20 different push notifications, what will happen at that point? In the past, when these financial grade systems were built, they were built beyond the model of iterative access. You are in a bank, you're making a transaction, you will have one or maybe three transactions at a time. As we have scaled this to agents, where a single person can have hundreds or thousands of agentic workflows running for them, we'll probably see a more risk based or more soft agentic inference based approach towards approving transactions, which will slightly look like most normal interactions go through without additional friction. But if we run a risk score and we determine something that needs additional friction, we can escalate it up. And the way to solve that is to use step-up authentication, which you can do today, even with all the current specs. You can use an RFC that tells us about sending the response as an error, but also telling the client that the error could be resolved if an access token with a stronger method can be presented. And if we make that work with a risk engine, the net result we get is we can now remove every single transaction from going through that approval process and expand long-term approval to the agent. Right? Thank you so much for joining us today as we talked about async interactions. There's a lot more that we're doing on async interactions, auth for headless agents. And if you want to join the conversation, if you want to collaborate and bring us new problems, I go by Shrek Overflow on Twitter, and on GitHub, I'm Sam Shrek. Very happy to collaborate with you all and can't wait to see what you build with async interactions.